Welcome to the class, student. So today we'll do the next chapter, that is electrochemistry. In this chapter you will study about galvanic cell mainly, and little idea you have about electrochemistry. In class 10th you have studied about electrolysis, and the phenomena of electrolysis you have studied, and this is done in a device. That device, you know, the beaker with two electrodes, electrolyte and external circuit through the battery, that all you have studied. So that device is called electrolytic cell. So in electrochemistry mainly we will be emphasizing upon electrochemical cell. Electrochemical cells, these are of two kinds. One is electrolytic cell, and the other is galvanic cell, which is also called voltaic cell. This is also called voltmeter. You have studied that. So in electrolytic cell, that is your electrical energy. You know the phenomena of electrolysis, anode and cathode. In a beaker, you know, electrolyte is taken and electrodes, anode and cathode, they are linked to the negative and positive terminal of the battery. This is your electrode, electrolyte, and when the circuit is complete, the bulb will glow, the current will flow, and in this case we are using the source of current externally, that is a DC current, battery. So in this case electrical energy is converted into chemical energy. Where this is first type of the cell if we talk about. On the other hand, in galvanic cell, the reverse phenomena. Chemical energy will be converted into electrical energy if this is B cell. So this is the fundamental difference between the two. And the second point of difference, you can see that this reaction is not spontaneous, non-spontaneous. This is non-spontaneous, but this is your A is non-spontaneous, but B reaction is spontaneous. Spontaneous means it will continue of its own. Third is, this reaction is not feasible. This is feasible, and this is also feasible. So this is the similarity. Feasible means easily it will be going on, taking place easily. So both of them are feasible. Then another point of difference, if you just see both characteristic, if we compare, that is oxidizing agent and reducing agent are in direct contact. and in this case this is A and B, not in direct contact. Oxidizing and reducing agents are not in direct contact here, and here they are in direct contact. So here chemical energy will be converted into electrical energy, and here electrical energy will be converted into chemical energy. The next point, if we compare, that is, in case of electrolytic cell, during the reaction, a new substance will form. The very common example, if I give to you, hydrolysis of water, electrolysis of water, you have studied hydrogen is collected at cathode and oxygen gas is collected at anode, water. Whereas in water is a liquid, you know that, and water molecules, water doesn't have characteristic of oxygen and hydrogen individually, and but these two gases can be prepared. You have studied in class 10 extraction of aluminium from alumina, there also new substances formed. In class 11, some electrolytic methods of salt you have studied, and those substances like sodium salts could be obtained by the phenomena of electrolysis. So in this case, new substances are formed. So reaction is a chemical reaction. You know, chemical reaction means chemical change where new substances are formed. In this case, the reaction is redox. Redox means reduction and oxidation will be taking place simultaneously. So you have to do galvanic cell in detail, and so I will be taking now the galvanic cell. So galvanic cell. So it is a device to convert chemical energy into electrical energy. So how this is constructed, that is very important. Some important point I will be highlighting, and that you should remember. So there are two ways to construct the cell. One is you just take a beaker, and in this you put a porous plate. The material of this porous plate, if you have seen candle in your water filter, that material. So of that a plate is made, is having very fine pores that is fixed in the middle. So it is creating two chambers in the beaker, and one side is filled zinc sulfate solution having concentration 1 molar, and other side a copper sulfate solution is filled, and that is also having concentration 1 molar. And in this copper rod is dipped. This is copper rod, or you can say copper electrode is dipped, and here a rod is dipped of zinc. So this is zinc electrode. Now these two electrodes are connected together through a galvanometer and here connected. So this is your galvanometer. When you have fixed like this, you will see that this is, if 0 is here, so needle is at 0 means no current is flowing. But when the two solutions are, here it is separated by porous plate. When these two solutions are connected through a U-tube, a glass U-tube, or you don't take U-tube here actually, we don't take this U-tube when we take porous plate. This porous plate is allowing ions to flow from this side to that side or from this side to that side, but it is not allowing the mixing of the two solutions physically, and therefore this is a partition between, so they are not in direct contact. Oxidizing and reducing agents are not in direct contact, separated. So when this porous plate is fixed and this wire is connected, then you will see that needle is now no more at 0, it is deflected to something. It is found nearly 1.0 volt reading. But now one more suitable, little more advanced, modified device is constructed of galvanic cell, which is more common. In that we take, and this one always we will be using. More higher I go, so I will have to write also little thing at the bottom. So we will have to take two beakers, and in one beaker I will take zinc sulfate solution having concentration 1 molar, and here copper sulfate solution having concentration 1 molar, and there is a zinc rod. This is zinc electrode, and here we have copper electrode. Then these two are linked together through the galvanometer. Okay, needle will be at 0, and now when a tube is fixed into a glass tube, which is, tube means it is now hollow, it is packed with, this is packed with a gel, agar and agar, in the U-tube, agar gel mixed with, agar and agar gel is used, and in this an inert electrolyte. Inert electrolyte, word you remember, inert electrolyte. I will tell you the meaning of inert, what does it mean. Electrolyte you understand, which will dissociate into its ion, like potassium chloride, potassium nitrate, etc. Okay, so here the salt bridge is packed with a inert electrolyte in a agar and agar gel, and as soon as the salt bridge is fixed, this is taken out and filled with this, packed with inert electrolyte, as I told you, KCl or KNO3, these electrolytes, these are filled in the mixed with agar and packed into it, and the cotton flag is put up there. So as soon as the salt bridge is fixed, this needle will show deflection from 0 to 1 volt. Okay, now so the salt bridge is having very important role that we'll see later. Now in this case, here you just see this cell, this is called one half cell, this is another half cell. So this half cell and this half cell, the two half cell is making one galvanic cell. So a galvanic cell is electrochemicals, your cell, which is consist of two half cell. One half cell is called oxidation half cell, and the other is called reduction half cell. Oxidation half cell is generally most of the books and most of the places you will see oxidation half cell is always taken on the left side, but it is not hard and fast rule. But you will find in most of the cases it is taken on the left hand side, and reduction half cell is taken on the right hand side. Why? Because in this cell the oxidation is taking place. That is what? Zinc rod, which is dipped in zinc sulfate solution. This part of zinc rod is containing zinc atom. So zinc solid, zinc atom is losing 2 electrons and is converted into zinc ion, and that zinc ion is passed into this solution in the aqueous solution. So loss of electron is taking place. So this is oxidation. So this oxidation is taking place here. So therefore this cell is called oxidation half cell. And here in this case, this half cell, reduction half cell, copper ions which are present here, they will gain electrons. These copper ions are in aqueous solution, physical state. It is important to be mentioned and compulsory to be mentioned. And then this is turned into copper solid. And here what do you see? That gain of electrons. So this is reduction. So here reduction is taking place. Therefore it is reduction half cell. Here oxidation is taking place. So this is oxidation half cell. You may have a question in your mind. Then why this is not showing reduction? Why here zinc ion is not gaining electron and turning into zinc, and why this here copper solid is not losing electron and turning into copper ion? See, these phenomena I will take more in detail, but here I just give you one very good tip to remember that how to decide oxidation half cell and reduction half cell. Oxidation and reduction reaction in this electrochemical cell, in this galvanic cell, depends upon the nature of the metal which is used in these two half cells. Zinc, you know, is much above in copper in the reactivity series. So zinc and copper do not have same reactivity. Zinc is more reactive than copper. So remember that always more reactive metal will be taken at your left hand side, and that will always be giving you the solving the purpose of oxidation, and will be called oxidation or will be constituting oxidation half cell. Whereas less reactive metal will be constituting reduction half cell. So more reactive metal will undergo oxidation reaction faster than the less reactive metal. Less reactive metal, in other words you can say, will undergo reduction faster than the more reactive metal. So more reactive undergoes faster oxidation, slower reduction. This is your less reactive metal is undergoing faster reduction but slower oxidation reaction. Take one example. If a half cell is made up, this zinc and copper example is given by the council, and mostly this is taken to be discussed the whole phenomena. But in place of zinc and copper, you get the pair zinc and lead. So zinc is more reactive than lead. What will happen? This zinc and lead. So here zinc is more reactive, it will remain on the left side. Zinc will be constituting oxidation half cell. Lead is less reactive, so it will be taken on right hand side and it will be constituting reduction half cell. If you take lead and copper, then lead is more reactive than copper. So lead will be here and your left hand side, lead will be constituting oxidation half cell and copper reduction. If you take your zinc and lead, Then zinc is more reactive than lead. So zinc will be here and lead will be there. So I hope you have understood that which metal salt solution must be used in oxidation half cell and what it should be in reduction half cell. This is very important part of this chapter, of this topic. The numerical reasoning question, that all is based on this. Okay. Now we come to the next thing here. So this is this half reaction, this is another half reaction. So this half reaction and this is taking place. Now look here, zinc solid is turned into zinc ion, electrons are accumulated, gathering here. So here electrons will be gathered, so concentration of electron will be more. Here your electrons are being taken into the solution and copper is getting deposited. So here electron concentration is decreasing and here electron concentration is increasing. So electrons will flow from higher concentration to the lower concentration. Electrons will flow from the electrode which have their higher concentration to the electrode which have their lower concentration through the external circuit. Electron is flowing from zinc to copper. In this case, remember students, in galvanic cell, that oxidation half cell, this is called anode, means the metal used in oxidation half cell is called anode. So zinc is anode and this is negative, just opposite of electrolytic cell. In electrolytic cell you have seen anode is positive. So in this it is negative and here electrons are being collected here. So more reactive metal will be solving the purpose of anode and here this is your cathode. Cathode is positive in your galvanic cell. So electrons will flow externally from anode to cathode, remember that. So this reaction is called oxidation. Oxidation half cell reaction. This is called oxidation half cell reaction. And this is reduction half cell reaction. So this is oxidation half cell reaction, this is reduction and then overall of the reaction. As many electrons are released here by zinc, a metal when it is converted to zinc ion is passing through the wire external circuit and coming on to the copper electrode where a deficiency of electron is there and is being consumed by copper ion. And so this common reactant and product will be cancelled. What we will be left with? Zinc solid plus copper ion aqueous will give zinc ion aqueous and copper solid. This is overall of the reaction and this reaction, the last final reaction, is called cell reaction. Net cell reaction or simply cell reaction. So cell reaction which is here, it is redox. Here this was oxidation, this is reduction and this is redox. This is zinc is converted to zinc ion is oxidation, copper ion is converted to copper solid is reduction. So it is a redox reaction. So the cell reaction is very important to write. You should know to write this half cell reactions, oxidation half cell, reduction half cell and then cell reaction finally. Now see the next thing. When zinc ions are coming into the solution, zinc atom is turned into zinc ion. So here zinc ion is being added. So here concentration of zinc ion is increasing. You started with 1 molar, but now it will be no more 1 molar, it will be more than 1 molar. So as the reaction will be in progress, cell is set up for some time, concentration of the oxidation half cell will change. Concentration of oxidation half cell will increase. Why it will increase? Because concentration of zinc ion will increase due to oxidation reaction. And here the phenomena will be just reversed. What it will be? Concentration of copper ion in the solution is decreasing. Why decreasing? Copper ion is converted into copper solid, so your concentration of copper ion is decreasing. So what actually is there? You see that here zinc ions are increasing more in number and here copper ions are decreasing. So what will happen here? Concentration of positive ion should increase, should be more than the positive ion in the cell. So there will be imbalance and neutrality will be disturbed. So this neutrality will be disturbed. What will happen? Reaction will be stopped further and electron loss and gain will not be balanced and reaction will be stopped. So cell will not work after some time. But when this salt bridge is put up here, the salt bridge is containing an inert electrolyte, say KCl or K2SO4 is generally taken, potassium sulfate. This will dissociate into potassium ion and sulfate ion here in this. Now see students, what happens? When zinc ion concentration increases here, then what concentration is decreasing? Sulfate. This is increasing, zinc ion concentration is increasing and sulfate ion concentration is decreasing in comparison. If you just see, amount of sulfate ion will be more and the amount of sulfate ion will remain the same what it was in the beginning, but as zinc ions are being added, so concentration of zinc ion will be less than the concentration of sulfate ion will be less than the concentration of zinc ion. So zinc ions are more, negative ions are less. So to maintain electrical neutrality between positive and negative ions in this oxidation half cell, what will happen? Some sulfate ion, and if you have taken KNO3, some nitrate ion will pass from salt bridge into this solution. And again what will happen? The concentration of positive ion and the concentration of negative ion will be equal, will be the same. So neutrality will be maintained here. In this case, concentration of copper ion is decreasing, concentration of copper ion decreasing, so sulfate ion concentration is increasing. So what will happen? From here to increase concentration of this so that there will be no imbalancing between positive and negative ion in this half cell, what will happen? Some of the positive ion will travel from here into the solution. So some potassium ion will travel and what will happen? The positive and negative charges will be balanced and thus electrical neutrality will be maintained. So this is the role of salt bridge. What is the important role of salt bridge? That is, it maintains electrical neutrality in electrolytes. How? That I have explained to you. Not only that, now when the salt bridge is there, since ions are migrating, so it is completing the circuit. If you see, the circuit is, external circuit is half. And when ions start getting travel, then the circuit is completed and then we see that current starts flowing. So as I told, as soon as we put the salt bridge, we see the deflection in the needle because the current has started flowing. So remember student here, in this galvanic cell, we have two connections. One is that is flow of electron is taking place, flow of electrons taking place from anode to cathode in external circuit. Okay, I write here just external, otherwise the space I don't have so much externally. Then flow of current is taking place from cathode to anode internal circuit. So external circuit, electrons will flow from zinc to copper electrode, and current will flow from copper sulfate solution to the zinc sulfate solution, from copper ion to zinc ion, or from reduction half cell to oxidation half cell. Current will flow, and electrons will flow from oxidation half cell to the reduction half cell. So this is the function of the salt bridge, very important. But here that is, I use the word inert electrolyte. The salt bridge is packed with a KCl or K2SO4 or KNO3. That is inert electrolyte. What is the meaning of inert electrolyte? Electrolyte, inert means this electrolyte KCl or KNO3 or K2SO4, it will not take part in redox reaction. It will not take part in oxidation half cell reaction, which I showed you. That is, zinc solid will be turned into zinc ion. It will not take part in that. This electrolyte will also not take part. The ions of this will not take part in reduction half cell. That is, copper ion is turned into copper solid by gaining electron. This was first thing. That is, it will not take, these ions of this will not take part, that ions of an inert electrolyte will not take part in a redox reaction, one thing. Second, it will not react with what? This electrolyte, inert electrolyte will not react with these electrolytes which have been taken in this oxidation and reduction half cell. In other words, that is, KCl will not react with zinc sulfate, KCl will not react with copper sulfate chemically, and so this is the meaning of inert electrolyte. So here I have told you some very important thing, and then here I have taken concentration 1 molar. 1 molar is a standard concentration, and temperature is kept 298 Kelvin. You have studied earlier, for solution the standard temperature is 298 Kelvin or 25 degrees Celsius. So at this temperature, when this concentration is there of the two electrolytes, the cell is a standard. Now I'll teach you how to write the cell notation. So cell notation, this is very important thing for numerical and for other reasoning question. So what is cell notation? Cell notation is symbolic presentation of this galvanic half cell. So that I show to you how. So as I told you, oxidation half cell is always on the left hand side. So we will start with that oxidation half cell. So symbol zinc solid, that is like a rod. So one vertical line, this is indicating electrode, is dipped in zinc ion, which is aqueous and having some concentration. Here concentration is 1 molar, and if concentration is C1, maybe 1, if it is not 1 molar, if it is 1 molar, it is standard. If it is not 1 molar, it is not a standard, maybe 0.5 molar, maybe 1.2 molar. So whatever the concentration, that we will write here. If it is 1 molar, we will write here 1 molar. Okay. Then this is separated by a salt bridge. This double vertical line indicates salt bridge. And then the reaction is what? Electron is flowing from zinc rod to the copper, from oxidation half cell to the reduction externally. So electron is flowing externally from this side to that side, where it is coming on copper electrode. But what is the reaction taking place? Copper ion is in solution. Suppose this is having concentration C2 or 1 molar. So concentration C2, or you can say 1 molar, whatever the concentration, and that is having an electrode of copper solid. So this is presentation of the galvanic cell through the symbol, and this is called cell notation. So this all I explained to you today about the electrochemical cell and how does it work. Just let me see the point that whether I have covered all the points required or not, so that yeah, I covered everything. I had jotted down. So this part we have done, and now we will do in the next class electrode potential. Electrode potential. So bye now, students.